All right. Hey, students. It's Mr. Rich. Good to see everybody tonight. It is, let's get our screen up here. And there I am. All right, everybody. So welcome, everybody. This is Mr. Rich. And every Sunday night at 8 o'clock, I go live on my YouTube channel here to answer any questions that my students have about math. Usually I spend the first 15 or 20 minutes going over some special topic. But today we're going to be going, everything's going to be ACT this whole session. So what I'm doing tonight is I'm working the ACT practice test, what I'm calling MC5. I don't know what the official number is of this particular test, but this is the one test, the one practice test that they've come out for the enhanced version for the ACT that they say is most like the level of difficulty that you could expect on the live enhanced version test that you take. And that most of you that are watching this are probably taking it on Tuesday in St. Johns County. We expect this one to be the most like what the level of difficulty will be on test day. A lot of the other practice tests that they have for the enhanced version that are in their red book that you may have purchased online, the students in the first enhanced versions of the test tell us that those practice tests were much easier than what they experienced on test day. And I think that that's true on both the English and the reading side as well as the math side. Certainly it's true. I've heard that on the math side of things. But this one practice test supposedly is more like what you could expect on test day. So I figured we would devote this whole session tonight by going over this particular practice test. I'm going to work as many of these problems as I can, do some coaching along the way. If you have any questions during the session, you can post them in the comments section if you're watching on YouTube. This is also streaming, I think, on X. And to submit any questions, you'd have to be watching it on YouTube, and you could comment in the comment section. You will notice that I put in the show notes a couple of links. There is a link there to the actual test that I'm working here tonight. And the link will take you to the ACT website where this test is posted, and it's got all of the sections there. We are just, of course, tonight focusing on the math section. That's all that I'm going to be working on here tonight. Okay, so if you are taking the ACT coming up this Tuesday in St. Johns County, you know that the math section, the enhanced math section is now 45 questions. It used to be, prior to last fall, it was 60 questions. They've pared it down to 45, and the time limit has gone from 60 minutes to 50 minutes. So there you go. You've got 50 minutes, 45 questions. So a little bit of extra time per question, probably not that significant, but that is what you have. A couple of things before I get into working problems on this test. Now, if you've taken the ACT before, you know that as you move through the test, the questions get progressively harder and more challenging. However, I always tell my students that I coach for the ACT to really consider this ACT to be broken up into two parts, really, on the math section. Think of it as problems 1 through 30 is the first section of this test. And those are really the part of the test there where the questions are going to get progressively harder as you go through. But I find, and I think most people find, that 31 through 45, they really stop getting progressively harder. Okay, those really are the harder questions on the test. They're all pretty much more challenging than what you see 1 through 30, and not necessarily more progressive as you go through it. For example, on some practice tests, I'll see what I would think would be maybe the most challenging question on the test to be in the 30s, maybe 37. I also find a typical pattern is that you'll see that maybe in questions 41 to 45, those last 5 questions, they'll put a few, I'll say easier, but maybe not so much easier, but faster questions that you could get rather quickly if you do understand the underlying concepts. So it definitely is to your advantage to work on your pacing on this test, right? You do not want to get into a position where you are not looking at like the last 6 questions because you just ran out of time. If you are running out of time as you get into 31 to 45, you need to be very selective as you move through those problems to pick the ones that you think are the fastest for you and make sure that you get your eyes on all 15 of those last questions, 31 to 45. All right. And I also coach my students that if you've got like 5 minutes left, maybe go look at the last five questions and see if there's two in there that look to be rather simple for you, because there very well may be, and you don't want to leave those two questions on the table. All right, I'm going to check to see if there are any questions that have come in that I can see. I don't see any. If you are watching live, um, feel free to put a comment in there. Let me know that you are watching. It looks like we've got a few people here watching live. All right, so I'm going to go ahead and work through a few of these problems that I've coached quite a number of students on this particular practice test, and I know what seems to trip them up, and I'm going to show you those particular questions that I have found. Now, I'm going to start you off here with question number 3, because I've had some really top scoring students miss this question, and it's meant to be an easy one. It says B, if given that B is 40 and C is negative 16, B plus C is equal to the product of negative 4 and what number? Well, B plus C, well, there's B and there's C. B plus C, 40 plus negative 16 is 24. So it's asking, what do I multiply negative 4 by to make 24? And that answer is negative 6. I've had at least 2 students make the mistake and choose 6. I'm not sure why they made that mistake. I do tell them, though, one of the ways that you can avoid making a mistake is spend a few extra seconds and write this out as an equation. Right? This says B plus C is equal to the product of negative 4 and a number. That's the equation. And then that forces you to go back and say, okay, well, what is B plus C? Oh, that's 24. And then your algebra there tells you that the answer has to be a negative 6 for it to be a positive 24, or just divide both sides by negative 4. Okay, so that was the first one that I wanted to show you. And let's go down here to this one. This is I would say a fairly challenging problem for being number 7 on this test, right? You're expecting questions 1 through 10 to not really be tricky at all. This one, maybe, if nothing else, it's wordy and takes a little bit of extra time. So this shows A, B, C, and D are on circle O. A and B are as far apart as possible. Okay, so that's just telling us that they are on a diameter. Okay, so that's going straight through the center right there. C is halfway between A and B along the circle. So that would tell me, right, that that is a right angle. If that's C is located exactly halfway between A and B along the circle. And then D is halfway between C and B. So what that means is that I've just made myself a 45-degree angle between the angle BOD is 45 degrees. It says, what percent of the area enclosed by circle O is enclosed by OCOD and arc CD? In other words, they want to know what percentage of the entire area is that little slice right there. Well, that little slice, since it is a 45-degree angle, I know exactly what percentage of that circle, that area of that slice is. It's 45 360ths, because there's 360 degrees in a circle, as I'm sure you all know, and 45 of the degrees is taken up by that slice. So I would go over to my TI-84, maybe make a fraction here, and do 45 over 360. It's 1/8. I would just do 1 divided by 8. Probably should have done that to begin with. And so it's 12.5%. That's going to be my answer. It's 12.5% of the area, because it is 12.5% of the total degrees that are inside the circle. Okay, so that was number 7 on that test. Now, next one that has caused some difficulties. Moving along here. Yeah, we'll talk about this one here. Let's talk about options here. right? They just simply want you to add those numbers. Well, I've been sick all week, so my voice is very hoarse. So I'm gonna have to take some sips here as I go, so so y'all can hear me. Well, what you would have to do is really simplify each one of those radicals because they looks like they have a common radical. Now, the easiest one to simplify would be the square root of 63 because I know that 9 times 7, that's the easiest one to factor into a product of a perfect square. So it's 9 times 7, right? 63 is. Since that's 9 times 7, I pull the square root of 9 out. It's 3 root 7. That helps because now I know A and B are not going to be the answer. And I know to divide these other ones by 7 in order to simplify them. So 175 divided by 7, right? That's 25. 175 is 25 times 7. So therefore, the 25 comes outside that square root as 5. So it's 5 root 7. And then I would take 112 and divide that by 7. And it's 16 times 7. So that's 4 root 7. So I have 4 root 7, 3 root 7, 5 root 7. 12 root 7 is my answer. Now, one thing that I do tell students that might maybe forget how to simplify radicals, don't forget the option that you do have in a situation like this. It's not the optimal way to solve it, but you can have your calculator give you that sum as a decimal. And then look at what the decimal is on your calculator and then run through each of the answer choices until you find the one that in decimal form matches the decimal answer that you got up here. So that's another option that you have. Okay, let's keep moving through this. Number 18 is the next one that I wanted to talk about. It does trip students up. They're not sure what to do with this triple ratio of 5 to 3 to 2. Okay, so I want to just talk very briefly about how to handle ratios on these tests, right? So hopefully you all know that if I did tell you that there was a ratio 5 to 3 between two certain measurements, that you would know that you could write that as a fraction, 5 to 3. And you would also know that if you multiply a fraction top and bottom by the same number, you maintain that ratio. In other words, if I multiply top and bottom by 2, I get 10/6. Well, that ratio is equivalent to 5 to 3 because it reduces to 5 to 3 or 15 to 9. So, or any number times both the 5 and the 3 maintains that ratio. So I could make it an x. So long, and so this ratio right here, so long as I multiply all three of those numbers by the same constant, I will maintain that ratio. So I really could just simply rewrite this as 5x to 3x to 2x and let those represent any of the numbers that I might possibly be looking for because they would have to maintain that ratio 5 to 3 to 2. So if I do write it that way, then it tells me that the sum of the three positive integers is 180. So I'm going to let the smallest be this, the middle, and the largest be those. And then when I add those up, I get 10x. And they said the sum of those three integers would have to be 180, which means x is 18. And that would mean that my smallest number would be 2 times x, or 36, 54, and then 5 times 18 is 90. And you know what? Sure enough, that sum is 180. So my answer is G, 36. It's the smallest number. So my advice to you is if you do run into one of these triple ratios, go ahead and insert a variable x next to each one, and you will maintain that ratio. And then you can set up any equation that they tell you is the relationship between those numbers. And then you can solve it algebraically. All right. So again, before we move on to the next question, this is Mr. Rich. You are at my live Q&A that I do every Sunday night at 8 p.m. here on my YouTube channel. And this is where I take questions from my students that they submit their homework questions to me through email or here in the chat in YouTube. You'll see my email there scrolling along the bottom if you do have a question, or if you have an ACT related question, something about the format or the pacing or the content of the test, go ahead and post that in the comments here in YouTube, or you can send an email to me there at askmrrich@gmail.com. So the whole night tonight, we are working through this practice test. And again, if you go to the show notes for this YouTube stream, you will see a hyperlink. Actually, there's two hyperlinks there. One hyperlink is the link to this actual test at the ACT website. The second hyperlink is what I would consider a very good math equations sheet for the ACT. So if you're looking for something that kind of is a 1 or 2 pager that gives you most of the formulas that you're going to need for this ACT, download that sheet that I have hyperlinked in the show notes for the stream. Okay. It's a 2-pager, and you know, you don't get a formula sheet on the ACT. If there's any formula that they're going to give you, it would be within the problem. There's no formula sheet. So you have to know your geometry formulas for area and for perimeter. Most notably, I would say circles. You need to know circumference and area formulas for circles. You need to know your trigonometric ratios, SOHCAHTOA. There's also formulas on this test on the law of sines and law of cosines that they expect you to know. And so all of those formulas that you need to memorize, go look at that formula sheet that I've posted there. I think you'll find it pretty helpful. All right, moving along. Oh, and by the way, if you're one of my students that has taken this practice test, I probably have a few of you that are watching that have taken it but have not been coached by me on the ones that you missed. If you do have a particular problem that I have skipped over that you want me to go take a look at that you missed, then drop a note there in the comment section, and if I have time, I'll go back in and look at it. All right, moving along. I'm going to show you this problem 19. This one actually had me kind of confused when I read it. And I still haven't totally figured out why this is confusing, but it is. Jeremy reaches into a box in the closet. The box contains 10 gloves that make up 5 matching pairs. He picks one glove at random and he puts it on. Then he picks another glove at random. What is the probability that he has picked a matching pair? Well, since he's already picked one glove and put it on, that means there's only 9 left. So for a probability calculation, we have to put the total number of outcomes possible in this random event in the bottom of the fraction. And so there's only 9 gloves left. Now, how many of those 9 gloves are going to match the one that he put on? Well, the answer is 1, okay, because they are in pairs. So he picked one at random. Only one of the 9 are going to match the one that he just put on. So the answer here is 1 out of 9. Now, I don't know if I've had students that more than one student has picked 4 out of 9. And I think one of the students I talked to, we kind of concluded that maybe it's because our brains are thinking they're matched by right hand, left hand, maybe. But that's not what this says, right? If it was just about right hand, left hand, then the answer would be 5. Because if he pulled a left-handed glove out, there would be 5 right-handed left. And 5 out of 9 is not even an option. But at any rate, the answer here is 1 out of 9. Only one is going to match the glove that he pulled out on the first selection. So I thought I would just show that one to you. Okay, well, let's keep going here. I want to get to maybe some of the more challenging ones. 22 is one that a number of my students have missed. The first term of a certain sequence is -10. So I'm going to stop right there and make this comment. They do expect you on the ACT to know what an arithmetic sequence is and what a geometric sequence is. So you learned this I'm pretty sure it was an Algebra 2 concept. We definitely go in pretty deep in AP pre-calc on arithmetic and geometric, but arithmetic sequences are sequences that the terms of the sequence go up or down by a constant amount. The geometric sequences are lists of numbers where they keep going up by a common multiplier. But there's also a third type of sequence that they use on this test, and it's just anything other than an arithmetic or geometric. And that's what this sequence is, right? They're just telling you, follow the pattern. It says the first term is -10, and then the next one is a 1, and then each subsequent term is obtained by adding the two immediately preceding terms. So if I want the third term, it's telling me I need to go back and look at the two preceding terms and add them together, right? It says adding the two immediately preceding terms. So if it's -10 followed by a 1, that sum would be a -9. The fourth term would be the sum of its preceding two terms. I would have to look backwards to those two, add them together, I would get a -8. They want me to get the fifth term, which would be the next number, and it would be the sum of those two preceding terms, -17. There's the answer right there. All right, next, let's find some more problems here. It's not quite 8:30, so I think we're on a pretty good pace here to get through some challenging problems here. Let's take a look at this geometry problem. I have had some students miss this because they weren't sure what they meant by vertex angle and base angle. When it comes to isosceles triangles are triangles that have two congruent sides. They generally look like this. We'd like to draw them with two obviously maybe longer sides and then a shorter side, something like that. Well, these two angles, I think we call those the legs, although I'm not sure about that. But I do know that this third side that is not one of the two congruent sides is called the base side. And these are the two base angles. And these two sides would be congruent. And then we also know in isosceles triangles that the two opposite angles from the congruent sides are also going to be congruent. So these two base angles are the same measurement. The vertex angle is the angle that's up here. That's not one of the congruent angles. So the vertex angle is 40 up here, which leaves 140 degrees to be split between those two base angles. So 140 divided by 2 gets me to 70. So that's going to be a 70 and a 70. So that's going to be my answer right there, 70. All right. So that is that. See if there's anything else that I wanted to mention about the isosceles triangle. I think that's it. All right, another geometry problem here, 26. Equilateral triangle ABC. So what are equilateral triangles? Those are triangles that the three sides are the same length, and therefore all three angles are the same measurement, which means all of the angles are 60-degree angles here. One concept from your circle unit in geometry that they do want you to know on the ACT is that anytime you have in a circle what we called an inscribed angle, that is an angle that's formed with its vertex on the edge of the circle, and then it progresses out towards the other end of the circle, these inscribed angles, when they hit the other side of the circle, they form or they intersect here what we call an arc. And the degrees of that arc are going to be twice the degrees of the inscribed angle. So if that's a 60-degree angle, that is a 120-degree arc. And there it is. It's 120 degrees. Now, it is true. You could kind of look at this and realize that this triangle does break up the circle into what looks to be three congruent different arcs. And if they are congruent, then 360 divided by 3 would be 120. They all three have to be 120. So anyways, that's another way that you could look at that problem. But it really is a matter of those inscribed angles times 2 give you the degree measurement of the arc that they intercept on the other side of the circle. All right, let me give you a tip on geometry problems in the XY coordinate system. So I always coach my students that when they encounter a geometry problem in the XY coordinate system, most of the time they want to go ahead and draw the picture. And so you want to plot these points on your own sketch on scratch paper on the test. So what you're going to do when you draw a picture, if you're going to do it to try to help you solve this problem, you want to do it in the following manner. If I'm going to do Angelo's house at 4, -3, I'm just going to pick that point on the x-axis to be 4 and this point down here to be -3. So there's Angelo's house. I'll give it letter A for Angelo. And then Ella's is at 4, 7. So I would come out to 4, and then I would go up maybe and call this 7 on the y-axis. So that would be Ella's house at the coordinates 4, 7. Troy is at -2, so I'll just come out here and randomly, sort of randomly, but kind of proportionally call that -2 and come up here to y = 7. And there's Troy. And then Yoko is at -2, -3. So what this shows me is that they have given me a very nice rectangle like this. And it says, which the following is closest to the area in square miles of this rectangle? Well, I now can see the dimensions because this distance right here across my rectangle, 2 to 4, that's a width of 6. The height or my length of the rectangle goes from 7 to -3. I know that that's 10. That area is 10 times 6, it's 60. And this tells me each coordinate unit represents 1 mile. So this is 10 miles by 6 miles. It's 60 square miles in the actual, the real locations. That's my answer, 60. So I think it is worth drawing out that very neat sketch and plotting the ordered pairs on your XY axis so that you can measure the distances along the X and Y axis. So that is number 27. All right, moving along. Let's talk about trigonometry. So when you get to a trig problem in questions 1 through 30, almost always it's just going to be a pretty straightforward SOHCAHTOA problem. That is going to be what it is going to be, SOHCAHTOA. And then your job in these right triangle trigonometry problems is to look at the answer choices first and see which angle it is that's involved in the answer choices that you're going to make your selection. And this is obviously a 40, but this is a 50-degree angle up here. And the answer choices could be relative to 50 degrees. So, and they have done that before, but they're all with regard to the 40. So then you're going to take a look at what the sides would be labeled that are involved in the calculation. This side that I'm trying to find the height of that tree would be the opposite side from 40 degrees. The 18 is the adjacent side. So this involves opposite and adjacent. So I'm definitely selecting tangent as my trigonometric function that I'll use in this problem. And so I'll say now that tangent of 40 degrees must be equal to the ratio of the opposite side divided by the adjacent side. The opposite side is X. The adjacent side is 18. I got that. And then what you want to do here, students, is go ahead and cross multiply. When I'm solving this for X, I'm going to multiply X times 1 and set that equal to the other diagonal product, 18 times tan 40. Okay, and that's going to give you answer A. Right, it's all your X is solved right there after you cross multiply. Now, I do show my students this, you want to be careful on these problems because if this was flipped around and they wanted me to find that distance and they told me that that height was 18 feet, well, what would my tangent have looked like? I would have written down a different problem because, or at least a different equation because opposite over adjacent would have become 18 over X. I was going to get rid of B and C because those have the wrong function. My A and B both have my tangent of 40. But in this case, when you cross multiply, you haven't solved for X right away. because you're going to get x is equal to tangent of 40 degrees equals 18 times 1. And then you have to divide both sides by tangent of 40. And then your answer is going to be the other option that we had in our multiple choice. That would have been D if those were flip-flopped around. So my point is, make sure that you cross multiply and then use proper algebra techniques to solve for the variable of interest. And let's go to number 30. Yeah, this is a very interesting problem here. This, and right here, right, we're at the end of what I was calling section 1 through 30, and we're about to get into 31 to 45. And I'm going to talk about a pacing strategy that you want to have for this test, because if you've taken the ACT and you know that you have a fixed 50 minutes on this test, you don't have extra time approved, it's a lot of this is going to depend on pacing, because it's very difficult to get through this entire test. But I have a strategy for you that I'll share with you here in just a minute. Now, they show a number line that goes from 0 to 8, and then they've labeled these points that look to be evenly spaced from 0 to 8, A, B, C, D, E. And it does say that they're divided, the line segment is divided into 6 segments of equal length by points A through E. And it says, which of the following statements about the square root of 8 is true? They want to know where the square root of 8 is. All right, well, first of all, I need to know what the square root of 8 is. So I'm going to go ahead and calculate the square root of 8 on my TI-84. Okay, they're talking about the number 2.83 approximately. Now, what I'm going to have to do is figure out what these coordinates would be on this number line. So I have to take this distance from 0 to 8, which is obviously 8 units of distance, and divide it into 6 equal pieces. That would mean 8 divided by 6 is 1.33. It's 1 1/3, but let's go with decimal here. That would mean that point A is about 1.33. Point B is about 2.66. C would be about 5. Right? I would add another 1.333. And so on. But now I can tell where 2.83 is. It would have to be somewhere between B and C. So J should be my answer right there. Okay, so that's the way you want to do it. And I will make this as a general comment that when it comes to comparing numbers that are square roots or radicals, or if they are fractions, converting them to decimals sometimes is going to be your best strategy. All right, now before we get into some problems here on 31 through 40, I just want to take a few minutes and talk about your pacing strategy. So here is what I want you to think about. If you are, and I'm just going to make some general comments here about your score. If your last ACT was maybe in the low 20s, and you're trying to get on your next ACT, we'll say to maybe a 27, somewhere in maybe, in the upper 20s to mid 20s. Let's say, a modest increase would put you to maybe 25 to 27, somewhere in that range. And then what your objective is to really nail 1 through 30. You want to spend a disproportionate amount of time on questions 1 through 30 because you have the best chance to get those right. 31 through 45 are going to be much more challenging for you. So you want to don't fly through 1 through 30 thinking that you've got to answer all 45 questions, because you do not. If you do really well on 1 through 30 and maybe can cut your misses down to 2 or 3 or 4, and then you take 31 to 45 and maybe you answer the 5 easiest questions of those 15 and guess on the rest. And let me tell you about guessing, right? When you make guesses, pure guesses, you're going to answer straight down one column on your answer sheet. Don't Christmas tree and select different column selections. Go straight down, AF, 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 or BG, 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 straight down the line. But if you can pick 5 of your easiest and guess on the rest, then you have a good shot at getting 7 or 8 of those correct, and you're going to hit your goal, right? If you are, say you're in the mid 20s and you're trying to get to a 30, maybe trying to break 30, then yeah, you're going to want to do really well on 1 through 30 and just have a few misses, but you need to be pretty efficient and fast through those, because what you want to do is you want to be answering maybe a 10 of those 15 and guessing on 5 because you looked at those 5 and you're like, I have no idea, or that looks too hard, I don't have time. But you can be selective and maybe try to get 10, answer 10 and guess on 5. And then that's going to get you really to your goal. But my main point is, unless you're somebody trying to get to, like, you're at a 34 and trying to get to a 36, your success is going to be determined on 1 through 30. That is where you're going to earn your points. And that's where you've got to do really well. And you've got leeway on 31 to 45 to not be as good on those and still hit your target. Okay. So I tell students to spend a disproportionate amount of time. So if you've got 50 minutes on this test, you should be spending around 40 minutes on those first 30, leaving yourself maybe 10 minutes to be selective on those last 15 questions. Okay. Now, if you're trying to get yourself to a 30 or in the low 30s, then you're going to need to be a little bit faster maybe and spend 35 minutes on those first 30 and then the balance on 31 to 45. Okay. So that is that's just my recommendations there as far as how to pace yourself through that test. 1 through 30 is where the money is going to be made for you. All right. I want to show you 31. It is a very unique problem on probability. It says that Dion often flies his kite. He can only fly on days with wind. He does not fly on every day with wind. For any given day, let event A be that there is wind and B be that Dion flies his kite. Which of the following values can this be? And if you haven't taken a statistics or probability class, you may not even know what that notation is referring to. That is a sentence that says, what is the probability that both of those events occur? In other words, what's the probability that there is wind, that's event A, and that Dion flies his kite? And they want to know, what could it be? Which of the following could be the probability that that happens? Well, let's look at the answer choices, because we have to use a process of elimination here. We have to know that probability of any random event has to be somewhere between 0 and 1 inclusive. It could be 0, could be 1, but it can't be less than 0 or greater than 1. So D, out. Now, what we know about what they were telling us here is that he does fly his kite when there's wind, but not always when there's wind. Sometimes there's wind and he doesn't fly his kite. Okay. Yeah. Who's going to fly their kite every single day? Well, on every day there's wind, he's not always flying the kite. So there's no way that the probability could be 1, because that would mean that it is with certainty that he's flying his kite. And it can't be 1. But there are some days when he does fly his kite with wind. So the probability could not be 0 either. So it has to be somewhere between 0 and 1. Therefore, that probability has to be a half. Okay, so that's how that problem shakes out right there. Okay, number 32. Don't forget that if you encounter what we call a rational expression, that is a fraction with variables, if you're going to simplify it, and for sure, when you compare that expression to all of the answer choices are a simplified version of this. You have to factor and then cancel the common factors between top and bottom. And I'm not going to go into that on this problem, but you do have to know how to factor. All right, this is a very good problem to factor because it requires you to use the GCF. It requires you to use the difference of 2 squares factoring. So if you try that, expect to use that. But then it also expects you to do a quadratic factoring, because this denominator right here, after you pull out an x greatest common factor, it will be a quadratic. And so you get practice on this problem on all 3 of those. Okay, moving along. I'm not going to work this. I'm going to give you a general strategy that I give to all my students. Anytime you encounter a problem that has an equation that is one complete fraction equals another complete fraction, you don't think twice. You automatically transform the equation by cross multiplying. You take this cross product and set it equal to that cross product. All right, next one. Okay, I have found quite a few students are not sure what to do with what they call piecewise functions. They want you to find f of g of -1. This is what we call a composition of functions. It's functions that are within functions. What you have to do to get this problem right is you have to start with this inner statement right here. What is g of -1? It wants you to go to the function called g right here and plug a -1 in for an x. But since it's a piecewise function, it has two pieces to it. It has a top piece and a bottom piece, two separate expressions. You have to pick the right one based on the x that you're plugging in. So you have to look at these statements over here. This says use this top piece for g of x if the x that you're plugging in is less than or equal to -1. Well, my x is a -1, so I need to use this top piece to evaluate my function g. This says only use the bottom one if you have a value that's greater than -1. So I'm using the top piece. When I stick a -1 in, the absolute value of -1 is 1. 1 plus 7 is 8. So g of -1 is 8. So therefore, the next step would be to replace that with 8. And now I need to do f of 8. I come up to my f function. Since my x value is 8, I need to use my bottom statement right here, x greater than or equal to 0. 8 is certainly that. 1 minus 8, -7. There's my answer. Piecewise functions. One thing that I do want to show you about your TI-84, I assume since most of you watching this either live or the recording of it are going to be St. John students, you probably are using the TI-84. The TI-84 does have an imaginary button I down here, this blue I that you can see down here on my decimal button. So if you've got the more recent TI-84 Plus CE, the color screen version of the TI-84, it does complex numbers. So this answer right here, you actually could just rely totally on the TI-84. So I do 7 plus 4, hit the second function button, and then the I button, close it off, and then raise it to the second power. It will go ahead and do that for me. 33 plus 56i. Got it. And then we are done. All right. I'm not going to spend a lot of time on 40 other than to tell you, make sure that you know the definitions of the number types. Okay. You need to know what are rational numbers and what are irrational numbers. In fact, it's so important. I'm going to tell you what that definition is. And then you also want to know what imaginary and complex numbers are, but we really don't have time to get into that. So what are rational numbers? Well, all real numbers can be broken up into rational or irrational. Now, I'm going to tell you first what irrational are, the non-rationals. There's two types that you need to know of. Pi and E are the first type of irrational. These are mathematical constants that are irrational for the following reason. They don't repeat themselves. They are decimals that never repeat, but yet they never end. That's irrational. It's an irrational number. And also the other type of irrational number is a square root of a non-perfect square, like the square root of 2 or the square root of 10. numbers that are not perfect square roots, because they too are decimals that never end and never repeat. So those are irrational. So what are rational? They're everything else. They're called rational because the root word ratio means they are ratios of integers. So rational numbers include like fractions like 1/3, 1/4, whole numbers, 2, could be negative integers, -4, could be negative fractions. Okay, they are ratios of integers, which is a lot of numbers, fractions and non-fractions. Okay, the only thing that are not are decimals that don't repeat and don't end and don't terminate. And that's what we call the irrationals. Now, it is true, though, you could take two irrational numbers, like the square root of 2 and the square root of 2, and you could multiply them together and get a rational number, right? Because the square root of 2 times the square root of 2 is the square root of 4, which is 2, and 2 is a rational number. Okay. Anyways, I just wanted to go over that. That is an important part of the ACT. So now we're in these last 5 questions of the test 41 to 45, and I'm going to work a few of these. Now, if you're an AP pre-calc student, you should be a relative pro at solving exponential functions. Okay, so if you're solving this for x, you would divide both sides by 3, and you get e to the x equals 4. And you know that logarithms are what we use to reverse exponentials. If I'm trying to solve for a variable that is trapped up in the exponent, I'm going to use a logarithm on both sides of the equation that will get rid of this base e, and that's what's called the natural log. So what I'm doing as an algebra move is I'm taking the natural log on both sides. Because the natural log, which is log base e of e to the x, those cancel each other out. It leaves me x. And on the other side, I have the natural log of 4. That's my answer right there. Now, the truth is, if you did not know how to do that, you do have another option. Although by the time you get to problem 41, you probably don't have a lot of time left. But you could put these into your calculator and get a decimal answer for all of those numbers and plug them in here and see which one of these, when you take 3 times e raised to these answers, would give you something very close to 12. And then you would see that that is going to be your answer. All right, let's show you 42, a geometry problem. Well, they show you a triangle, and they do tell you that this is a right isosceles triangle. Well, what are the right isosceles triangles? They are 45, 45, 90 triangles. And remember what I told you, that if you have an inscribed angle and you project that angle out to the intercepted arc out here, right? This angle comes out and creates arc AB. That arc has to be twice the number of degrees right there. So that is a 90-degree arc. Well, 90 degrees on an arc is 1/4, right? It's 90 out of 360. It's 1/4 of the entire distance around the circle. So all I really need to do to get the length, right? It says, what is the length in centimeters of arc AB? I just need to find the circumference. The circumference, you need to know that formula, is 2 pi r. The radius here is 10 centimeters, right? Tells us. That means my radius is 20 pi. But that arc takes up 1/4 of that circumference. So my answer is 5 pi. 20 pi divided by 4 gives me the length of that arc, 5 pi. And then I want to go to 45. So this one right here, number 45, is a topic that you covered in Algebra 2, usually first semester in St. Johns County. And it was about how to find an inverse function. It's really simple if you just remember what is an inverse function, right? Or how to find one. If I give you a function and tell you to find its inverse, the process that we taught you was to swap the variables x and y. So this f of x, which is a stand-in for y, that changes to an x. And then that x inside the third root there is converted to a y. And then once you make that variable swap, then you go through the algebra steps to re-isolate the y variable that you just created. And when you do that, you've got the inverse function. So what I would do to wipe out this third root, I would raise to the 3 power on both sides, right? That's how you inverse or get rid of a third root. So that would leave you x to the third. That 3 power negates the, excuse me, the third root, and I'm left with that. I would add 1 and then divide by 2. And that is my inverse function. And we actually change that to be inverse f inverse of x. That's my inverse function right there. So I would consider that fairly easy for one of the problems in the last 45 or the last 15 questions. Fairly easy. I'm going to say it's fairly fast if you're, halfway decent at algebra. So that would be one that you wouldn't want to leave undone. It'd be one of the ones that you would definitely want to get your eyes on and answer that question. All right, checking to see if any questions came in. I don't think they did. No questions. All right, we do have a few minutes left. If you are watching live, we got a few people watching live. If you have some questions or a particular question on this test that you want me to work, post a note in the comment section here in YouTube, and I can work that problem. I'll give you a few other things that, since you've got maybe 36 hours maybe before you take this test, or a little more than 24 hours. Some other things that you might want to look up to be sure that you know how to do. I think it may be worth you doing a little bit of looking at matrix problems. There was a very easy matrix problem on this test that I didn't work, but know how to multiply matrices together. Okay, it's worth going and doing a YouTube search on ACT matrices and see if you can find a short YouTube video that shows you what you need to know about matrices on the ACT. I think that would be worth it. So that would be one thing to look up. The other thing that I didn't touch on tonight that you still have time to brush up on is how to work law of sines and law of cosines problems. Don't have time to get into that now, but definitely you could learn that and take a look at that in about maybe 3 seconds, not 3 seconds, but about 3 or 4 minutes of time if you devoted some time to that to brush up on it. Okay, and then the third thing is learn about equations of ellipses. They are very, very similar to equations of circles. Okay, so these are things that don't pop up on every test. I'm talking about difficult matrix problems like multiplication. That's not on every ACT. Law of sines, cosines, I think is probably more of a 50-50. Sometimes they're there, sometimes they're not. I would say the same with ellipses. It's kind of hit or miss whether you're going to see that on your test. All right, so again, just some last words too about resources. If you are interested in looking at this practice test, it is hyperlinked in the show notes here on this video. And so you can download that. I also have a review sheet for you to review that I've hyperlinked in the show notes. That's a 2-pager that gives you the formulas and the basic concepts in math that you need for the ACT. So that's a really good study sheet over the next 24 hours as you get ready for your test. Make sure, you got to have your calculator with you. Be sure that if it's a TI-84 and it's one of those new colored versions, that you charge it up, right? You want to be using the same calculator during the test that you've been using for the last year or two in your math classes. Charge your calculator up. I also, you're welcome, James. And I also do recommend that you get a good night's sleep. Always, I'm sure your parents are going to tell you that. And in the morning, don't do heavy on the carbs, right? You don't want a big sugar spike right before you go into a test and then halfway and get a sugar crash. So try to, eat more on the protein side of things than, a bunch of pancakes and syrup. So try to eat more eggs and bacon, maybe if that's something that you eat, but more protein, less carbs, I think would be a good idea to keep you alert throughout that whole test. And then I'll just leave you one other thing about test day. They'll probably hand out scratch paper. You can write on your test, I assume your test booklet, but if they hand out scratch paper, make sure you have plenty of scratch paper to start with. If you raise your hand and ask for more scratch paper before the test starts, they're supposed to give it to you. So be sure that you have plenty of scratch paper to work with. And other than that, as my voice is starting to give out, we will call it a night. And I wish all of you the best of luck on Tuesday. Don't stress, right? Because the ACT and the SAT are one of those tests that they're not final, all right? You're going to have another shot at this. So go in there with lots of confidence. Give it your best shot. You'll get your score in a couple weeks, and then you can decide your plans from there. Okay, everybody, I do appreciate you watching tonight. Remember, every Sunday night, 8 o'clock, I'm going to be here answering math questions. Feel free to join in or watch the recorded video afterwards. All right, everybody, have a great week ahead, and I'll see you at the next one. Bye.